Question 2. Chlorine is a reactive yellow-green gas and is a strong oxidizing agent. So why is a strong oxidizing agent? Okay, as all of you know, when chlorine dissolves in water, it forms two acids, HClO and HCl. The hypochlorite acid will further decompose to form the chloride and the oxidizing agent. This oxidizing agent used to kill bacteria by breaking their cell wall. Okay, so very easy, the function is just to use to oxidize and kill bacteria. Part B. 1. Construct the equation for the first IE of chlorine. Okay, it must be gaseous atom of the chlorine. So 16 bowl must put, so it's gaseous form. Make sure it's atom. To form 1 mole of this gaseous ion, and of course release 1 electron, 1 mole of electron. So it must be 1 mole of gaseous atom to form 1 mole of gaseous ion, release 1 mole of electron. Okay, part 2. Explain the general increase in the first IE of the period 3 elements. So we know that when across period, two things that need to relate. That's the proton number. Across period, proton number increases, and at the same time, the shielding effect is almost constant. Why is almost constant? Because when across the period, the inner shell actually is same, means the inner electron shell, they are the same. That's why the shielding is almost constant. Shielding mostly contributed by inner electrons. Because of proton number increases, but the shielding almost constant, therefore it's end up with a greater nuclear attractions to the valence electron, and the electrons harder to remove, and the first IE increases. More energy needed to release the electron. Part C. The halide ion, X negative, so it's can be chlorine, bromine, iodine. Show clear trends in their physical and chemical properties. Part 1. State and explain the relative thermal stability of the hydrogen halides. Thermal stability is how stable is the compound when we heat it. So we know that the bond energy of HCl is highest because the size of chlorine is smallest among these, and the attraction of the nucleus towards the shared electron is small. That's why it's harder to break. So the bond energy of HCl is higher. The bond energy of Hi is lower. That's the reason why this Hi has the lowest thermal stability among these three. So you just need to say thermal stability decreases down the group because of the bond length is longer. Longer means size is larger, and the bond energy therefore is decreases. The energies need to break the bond is lesser. Now next part. Just fill up the oxidation number of this sulfur in the compound. HSO4 negative. Oxygen's -2 times 4, so it's -8. Overall charge of the ion is negative. So we know that sulfur must be +6. This one SO2, -2 times 2, so it's -4. So sulfur must be +4, because the molecule is neutral. H2S. Hydrogen is positive 1 times 2, positive 2. Sulfur need to be negative 2 because the molecule is neutral. Okay, part 3. Explain why sulfur-containing products are produced when each of these halides reacts with concentrated H2SO4. Why different sulfur-containing? As you can see, when we use a chlorine, halide chloride reacts with H2SO4, it will just form HSO4 negative. And the oxidation number of sulfur is positive 6. When we use bromide, sulfur oxidation number now decreases. When we use iodide, the sulfur oxidation number further decreased. So it's telling us that the iodide is able to reduce the sulfur more than the others because it can reduce the sulfur, its oxidation number to negative 2. So therefore, the answer is very easy. Because of the reducing power of the halides increases down the group. The iodide has greater reducing power because it can reduce the sulfur oxidation number lower. That's the reason. D. Chlorine reacts with aqueous sodium hydroxide in a disproportionation reaction. State what is meant by disproportionation. Very easy. When a species is both oxidized and reduced. Write an equation for the reaction of chlorine with coal. Aqueous sodium hydroxide. If it's coal aqueous sodium hydroxide, then it will form this NaClO. From here we know that chlorine initially is 0 oxidation number. So after reaction it can be negative 1 here. Negative 1 here, and this one is negative 2, positive 1. This one must be positive 1. So chlorine now it's being reduced and oxidized. This we call disproportionation reaction. Part E. 1. You just need to draw the structure of the Al2Cl6. This is a dimer. You just need to arrange the atoms alternately like this. After that, you just put a bond between the Al and the Cl all together, and you put the dative bond. The chlorine, so form a dative bond with this aluminium. This chlorine form dative bond with this aluminium. Then it's done. Because this one is just diagram, it's not dot cross. You just need to draw this dimer and show the dative bonds. Describe what you will see when solid aluminum chloride reacts with water. Because it says solid, so we know that Al2Cl6 or AlCl3 when it's dissolved, so what we can see is solid disappear. So solid dissolves. While dissolves, of course, temperature increases, XO. But this one, sometimes you're not really sure whether it's XO or NO. But this one is for sure. The solid aluminum chloride sure dissolves. And of course, the type of reaction is hydrolysis because the covalence won't break during the reaction. Part F. 0.02 mole of element Z react with excess chlorine to form 0.02 mole of liquid chloride. And the liquid chloride has formula ZClN. N is an integer. ZClN reacts rigorously with water to give acidic solution and a white solid. So from this statement, roughly we know that it's going to be SiCl4. Because when the SiCl4 reacts with water, it will form SiO2, the white solid. and of course the white fumes, right, HCl. So and we need to find the N using the calculations, so see whether it's 4 or not. When excess silver nitrate added to the solution, 11.54 gram of silver chloride's formed. Okay, part 1. Suggest the type of bonding and structure shown by the ZClN. So because it's dissolved and it reacts with water, so we are quite sure that it's a simple molecular structure and it must be a covalence bond in the molecules. And part 2, calculate the value of N in this compound. Okay, the first thing that you need to do is find the moles of silver chloride. Okay, 11.54 over the molar mass, you will get 0.08 mole. And this mole is same as the chlorine, the moles of chlorine or the chloride. Okay, 1 mole react with 1 mole, form 1 mole of AgCl. Okay, and we just try to compare the mole ratio between the compound, the element Z, okay, which is 0.02, to the moles of the chlorine, so 0.02 to 0.08, so we will get 1 to 4, so N is 4. Okay, part G. So this is reactions to form the dichloromethane. This one, final step, form chlorine. So give the name of mechanism for this reaction. Of course, it's a free radical substitution. Okay, so you need to use the UV. State the essential condition for the initiation step. So UV light needed to break the covalence bond between the chlorine atoms, right, to form these chlorine radicals. Give the electronic configuration for this chlorine radical. Chlorine radical is actually referred to the atom itself. So it's just a chlorine atom. Because this, in the first step, the chlorine molecules undergo homolytic fission. So means the shared electrons now is moved to the chlorine. 1 electron, okay, move to the chlorine to form the chlorine radicals. So therefore, you just need to give the electron configuration for the chlorine atom. 1s2, 2s2, 2p6, 3s2, 3p5. Okay, part 4. Identify the products of the step labeled in propagation 2. This one, propagation 2, the products. Okay, because this one is the radicals of CH2Cl. When these radicals approach this chlorine radical, so these chlorine molecules will undergo homolytic fission. It will induce the bond breaking. And after that, it will form the 2 chlorine radicals, this with another one. So one of the chlorine radical will form new bonds with this CH2Cl. Then it will form these products, CH2Cl2. And these chlorine radicals, right, is formed, reform or regenerate. And these chlorine radicals will go to the propagation 1 and do the same thing again. So that's why the product, okay, for this propagation 2 is this CH2Cl2 with the chlorine radical. Okay, name the type of reaction shown in the final step. Final step, this one. 2 radicals combine form a molecules. So this we call termination. Okay, suggest an identity of another organic molecule that is a product of the reaction of the CH3Cl and the chlorine. The better answer is this CH2Cl, CH2Cl. Why? Because we know that in the propagation is formed CH2Cl radicals, and the CH2Cl radicals, two of that, like this and this, they can combine, form a new bonding to form this dichloroethane. So this one can be formed, or it can form this one as well, means one more hydrogen atom gets substituted to form CHCl3. Okay, that's all for this question. Thank you.